Hello friends, here we are discussing about the solution of senior level problem statement of IRC 2016 Singapore. So this is, as you all know, this is the arena of our problem statement, and you can see two checkpoints over here. Here you have to place your robots. On the left hand side of the screen you can see on this checkpoint you have to place one robot named Trashbot, and on the another side this is for the Biobot. So first we are discussing about the Trashbot. So what we have to do with the Trashbot, first we have to follow this black line you can see over here, and you can see a lot of intersecting lines on these black line. So on the first intersecting line of this Trashbot, what you have to do, you can see a outline over here. Here we placed a scrap tire prop. You have to pick this prop, and after picking up you just have to again start following this black line, and on the second intersecting line you can see another prop box over here. Here we place the prop named plastic box. You have to pick this prop, and again you have to start following the black line. After here you can see another intersecting line over here. Here there's nothing to do with this, you just have to cross this intersecting line. And at the fourth intersecting line, what you have to do, this is our recycle plant area. So you have to drop both props of the plastic box and the scrap tire over here on the input side of the recycle plant, and then you have to pick from the output side uh, brick prop. And after picking up that brick, you have to start following this black line, and after some time you can see another intersecting line over here. Here also there is nothing to do, you just have to pass on this intersecting line, and at the last intersecting line on the right hand side you can see the construction area. You just have to place that recycled brick over here. So after this you can see on the right hand side, this is our Biobot. So what we have to do with the Biobot now, same, we have to follow the black line first, and on the first intersecting line you can see on the left hand side there's a prop box over here. Here we placed a prop named broken tree. You have to pick the broken tree from here. After picking, you just have to start following this black line. After following this black line you can see another intersecting line over here and a prop box. In this prop box we place animal waste, so you have to pick that animal waste prop from here, and again start following this black line. And on the third intersecting line, same, there is nothing to do, you just have to pass on this intersecting line. And after this you can see another prop box over here. So here we placed a prop named dead animal vehicle, so you have to drag this prop along with you. And after this you can see another intersecting line. Here also you have nothing to do, you just have to pass this intersecting line, and after this at the last of the intersecting line over here you just have to drop all the props in this MCD dump area. So after arena, I want to show you some sketches of the models which I made. This is the sketch for Biobot. Here we are connected two sensors at the front side, sensor 1 and 2, and along with the sensor we have two cranes to pick up both props. This is the left crane which we made to pick up the prop named broken trees, and this is the right crane which is going to pick up the prop named dead animal waste. And with the center this area we are going to drag the dead animal vehicle along with us till MCD dump area. And this is the sketch for Trashbot. Here also we are connected two sensors, and here you can see a left and right crane. With this left crane we are going to pick up the scrap tire prop, and with the right crane we are going to pick up the plastic box prop. Then again when we drop both these props from this right crane only, we are going to pick up the brick prop which is taken from the output of the recycle plant, and at the last we are going to place it at the end where the construction site. So now we are moving forwards to our program. First we are making the program for our Biobot first. To make our program a little bit easier, we are going to create some functions for it. So first click on create function block, and here the first name we are taking as forward function. So the return type we are taking as void. So now you can see a new window appears over here. So in this, what we are doing, we are making a function to move a robot forward. So for that we are going to select port 1 over here, and direction will be clockwise. And as we are connected two motors, so we have to drag one more motor direction block, and in this we are going to select port 2 and anti-clockwise. So these directions ask to move a robot move in forward direction, and a stop function block at the last. After this, we have to drag one more. We have to create one more functions that we are creating the right turn functions. So again, we are taking return type void. Click on create. Then you can see a new window appears over here. And now for this, we have to drag motor direction block. And in this, we are again selecting port 1 and direction will be clockwise, and another motor direction for another port. So here we are selecting port 2, and again direction will be clockwise for this again. So now a stop function block at the last. Now the third function which we are creating is for left turn. So again we are taking return type as void. Now after click on create, you can see a new window appears over here, and this we are again dragging the motor direction block, and here we are giving the condition to turn in left directions. So again port 1, and now direction will be anti-clockwise for this, and for the another motor direction block we are selecting port 2, but the direction again will be clockwise only. So now a stop function block at the last, and the last function which we are creating is the stop function. The return type again we are taking void. Click on create. Now and again one more window appears on the screen. Again we have to drag motor direction blocks. Here we are selecting the port 1 only, but the direction now will be stop. So for the second motor we are dragging one more motor direction block, and in this now port 2 and the direction again will be stop. So again the stop function block at the last. So these are four functions. You can make this program without these functions also, but to make our program little bit easy, we are creating these functions. And now we are making our main program. So click on main area, and this what you have to do first, you have to start with a start block. After this, as you all know, in our arena we have lots of intersecting lines. So for that intersecting line we are creating a variable for that. So for creating variable we have to select a data type, that is we are taking integer, and the variable name we are taking as count, and the default value we are taking 1. Now when you click on declare, you can see a new created variable block over here. We are going to use this created variable block. After this, you all know you have to make a basic line follower program. So for that we are taking a loop block first. Here we have to give the condition for the infinite loop. So we are giving a true condition, 1 is equals to once. It means this is the universal true condition. So this is the infinite loop block now, and as we are using two sensors, so we have to drag two sensor blocks over here, sensor 1 block, sensor 2 block. After this, you all know in the we have four conditions. With the all four conditions we can only make our line follower program. So for that, for the first condition we are dragging the if else statement over here. So in this if else statement we have to select multiple comparison. For the first condition we are taking the condition as sensor 1 is greater than 350. 350 means the medium line. Above 350 it means the sensor is sensing the white color, and below 350 it is sensing black color. So here we are taking sensor 1 is sensing black color. Now yes, we have to add one more comparison, and that is and comparison. Now with the second sensor, here we are taking the condition sensor 2 is also sensing the white color. It means value is greater than 350. Now we don't want to add any more comparison, so click on done. Now when our both sensor is sensing white color, so we have to move in forward directions. So we are dragging a forward direction function block over here. After this, for the second comparison condition, we are dragging one more if else statement over here, and this again multiple comparison. Here we are taking the condition sensor 1 as greater than 350. It means the sensor 1 is on white color. Now yes, for one more comparison, that is and in comparison we are taking. Now sensor 2 is less than 350. It means now sensor 2 is on black color. So now we don't want to add any more comparison. Click on done. When our sensor 2 will be on black color, but we have to turn towards left hand side. So we are drag a left function block over here. After this, for the third condition, we are dragging one more if else statement over here, and this again multiple comparison. Now we are taking sensor 1 is less than 350. It means now sensor 1 is on black color. And yes, that again the end comparison with sensor 2. Now sensor 2 is greater than 350. It means it is on white color. So now we don't want to add any more comparison. Now we have to turn towards right hand side. So we are dragging the right function block over here. Now this is the in else condition. You can find out the fourth comparison condition, that is when both sensors will be on black color. So for the plenty of intersecting line, we are declaring the first intersecting line as count 1. So for that we are taking one more if else block over here. In this, the relational comparison we have to take, but now the value of count we are taking here. So for the first intersecting line, we are taking count is equals to 1. It means our robot will reach at the first intersecting line. What we have to do at the first intersecting line? You can see there is a broken tree probe over here. We have to pick this broken tree probe with our robot. So here what we have to do first, we have to stop our robot. So we have to drag a stop function block over here. So for stopping time, we have to drag a time block with this. Here we are taking stopping time, that is 2000 millisecond. It means 2 seconds. After stopping 2 seconds, our robot will pick the object. So for that, the left crane which is going to pick up the broken tree probe, we are going to connect that uh, crane with port 3. So to lift that crane arm up, we are taking anti-clockwise direction which is connected to port 3. After this, we have to declare the time. So for how much period of time our crane will move. For that, we are dragging a time block over here, and this we are giving the time period of 3500 milliseconds. So our crane arm will move in up direction for 3500 milliseconds. After that, we have to drag one more motor direction block to stop our crane arm. So for that we are selecting the direction as stop and port 3, as this crane is connected with port 3. Now after stopping that arm, what we have to do, we have to cross the intersecting line, so our robot will again start following the black line. So for that what we have to do, as we created the forward function over here, we are taking that forward function block and we have to give some time period for this. So the time which we are taking to just cross the intersecting line, that is 600 milliseconds. After this time, you can see in the 600 milliseconds our robot will cross this intersecting line and again it will start following this black line. So after this we have to increment our value of contour at the last. So for that we are taking a variable arithmetic block over here, and variable arithmetic block we are taking count is equals to count plus the value constant. The constant value we are taking 1 here. So now here after this block our value of count will become 2. So for that we have to drag one more if else block over here, and this we are taking relational comparison again. Now we have to compare count is equals to 2. It means our robot will reach at the second intersecting line. And what we have to do at the second intersecting line, we have a probe on the right hand side, this animal waste probe. So we have to pick this one. So for that again first we have to stop our robot. So for that we have to drag a stop function block. Again we are giving the time period of 2000 milliseconds in this time block. Again 2000 milliseconds means 2 seconds, so you all know. And after this again a motor direction block to move our crane arm. Now this crane we are going to connect this crane with port 4, and when we select the clockwise direction, so our arm will move in up direction now. So again now we have to give some time to move our arm in up direction. We are taking the same time as with the previous crane, 3500 milliseconds time. After this again a motor direction block, and this motor direction block again we have to stop the crane arm. So we are selecting port 4 and the direction we are taking stop. After this click on set. Now after picking the probe, again you have to cross the intersecting line. So for that what we have to do, again we have to place a forward function block over here with a time block function. So the time block will managed to cross the intersecting line. Again we are taking the same time as 600 milliseconds. After this, at the last, we have to drag a variable arithmetic block. So that again we have to increment our counter. So to incrementing our counter, we are taking count is equals to count plus the constant value. We are taking that as 1 over here. After this, our value of count will become 3. For that, we have to drag one more if else block over here. Here we are taking the comparison condition now. Count is equals to 3. Now what will be at the third intersecting line? As you can see, at the third intersecting line we have nothing to do. We just have to cross this intersecting line. So for that, in the program we are dragging a forward function block over here. So just to cross the intersecting line, so after crossing the intersecting line, again we have to give some time. So the time block now, and the time block we again selecting the 600 milliseconds as we taking in previous intersecting lines. So after this, again a variable arithmetic block to increment our counter again. So in this arithmetic calculation, we have to select count is equals to count plus operand, again the constant value, that is 1. After this, our value of count will become 4. So for that, we have to drag one more if else block, and this if else block we have to give the comparison condition, that is count is equals to 4 now. So what happens when a robot will reach at the fourth intersecting line, but before fourth intersecting line, it has to drag this dead animal vehicle probe also with us. So when it will drag this along with this, and at the fourth intersecting line, there is nothing to do again. You just have to cross this intersecting line. So again, what we are doing, we are dragging the forward function block over here to cross the intersecting line. So we have to give some time also. So we are dragging a time block over here. So in this time block, we are taking time as 600 milliseconds. Click on set. Now again at the last, we have to drag a variable arithmetic block to increment the value of count. So again we are taking count is equals to count plus the constant value 1. After this, at the else condition, we can after this variable block, the value of count will become 5, and the value of 5 will come as in the else condition. So now, as this is the last intersecting line, the fifth one, so here we are not dragging any more if else block. We are giving the condition on the else. So for that, first what we have to do, we have to stop our robot at the intersecting lines. So for that, drag a stop block over here, stop function block, and here we have to give some time for this. So again for the time, we are dragging a time block over here. Now we are taking time as 2000 milliseconds again to stop our robot. After this, what we have to do, when we have to drop our both props in the MCD dump area. So for that, what we have to drag motor direction block again. So first we are taking as port 3, which is connected with the left motor, with taken the broken tree prop. So we are taking the anti-clockwise direction to lift the prop. So now we are taking the clockwise direction to drop the prop, and the another motor direction block for the another crane. So this crane is connected with port 4, and we are taking clockwise direction to lift. Now we are taking anti-clockwise direction to drop the prop. So after this, we have to give some time. So we are dragging a time block over here. After this, in the time block, we are taking again the same time, 3500 milliseconds. So in this time, it will drop this prop over here, and after that, again a variable arithmetic block at the last to increment the value of count. So again in this arithmetic calculation, we are taking count is equals to count plus the constant value which we are taking 1 always. So now this is the last final intersecting line. After this, we have to place a stop program block at the last. So for that, in controls, we are dragging a stop block over here. After this, we can save our project. This is the program for our biobot. So I'm naming this program as biobot robot. So after saving this, you can compile and burn your saved program. Now coming on the dashboard, this is the design of our dashboard. So now we are making program for dashboard. So same we are to make our program easier, we are creating some functions. So click on create function. Again we are creating the same function as we are taking in the previous one forward. This is the forward function and the return type we are taking as void. Now click on create. Again we have to give the same we have to drag motor direction blocks to move in forward. Here we are selecting port 1, again direction clockwise, set. One more motor direction block. Here also we have to select the port. We are selecting port 2 and direction now we are taking anti-clockwise. Now a stop function block at the last. Now we have to create one more function, that is we are creating right function and the return type again we are taking void. Now we have to drag motor direction blocks to turn it in right inside. So for that we are selecting port 1 again. Now direction is clockwise for port 1 and another motor direction block. And this we have to select port 2 for the direction is clockwise only to turn right. So now again a stop function block at the last. We have to create one more function. Now we are creating the left function. Now return type again void create. This is the new window you can see, and a motor direction block again over here. So now here what we have to do, again we have to select port and the direction will be anti-clockwise for port 1 now, and another motor direction block, and this also we have to select port, that is we are selecting port 2 and again the anti-clockwise to turn and left hand side. So the stop function block at the last now. The last function which we are creating is stop function again over here, and the return type in this the void again. This is the again new window. Again motor direction block we have to take. In this we are selecting port 1 but the direction is stop here. Another motor direction also we have to select a port and we are selecting port 2. Direction with the same stop over here also, and the stop function block at the last. So now again click on main area. Here we have to make our new program for the line follower. So for the line follower program, what we have to do, again we have to drag a start block at the starting, but as you all know, again this also we have plenty of intersecting lines, so we are creating variable over here also. But at data type we are taking as int, and the variable name again we are taking the same count over here also, and the default value 1 again. Now you have to drag this created variable block over here. After this you have to drag loop block, and this loop block we have to give condition for the infinite loop. So that we are taking is 1 is equals to 1. It means this is the universal true condition. The loop is now infinite. So after this again you have to drag sensor blocks over here. Sensor 1, this is sensor 2. To compare these conditions for the line follower, again we have to drag if else statement block over here. And this we have to click on create multiple comparison. Here we are selecting sensor 1 is greater than 350. Again it means it is on white color, and we have to add one more comparison, that is and in comparison we are taking. The second condition we are taking sensor 2 is greater than 350. It means this is also on white color. Now we don't want to add any more comparisons. Done. Now in this condition we have to move in forward direction, so we are dragging a forward block over here. After this we have to take the second comparison condition, so we are dragging one more if else statement, and this again multiple comparison. Here we are taking sensor 1 is greater than 350. It means the sensor 1 is on white color. After this we have to add one more comparison, that is AND comparison, and the sensor 2 we are taking now. Sensor 2 is less than 350. Now sensor 2 will comes on the black line, sorry. So in this now we do any more comparisons. So in this condition what we have to do, we have to turn in right direction. We are dragging a right function block over here. Now for the third condition we are dragging one more if else statement, and this again we are taking sensor 1 is less than 350. Now it means sensor 1 is on black color now. and we have to add one more comparison, that is end comparison. Again, now sensor 2 is greater than 350, means it is on white color. So now we don't want to add any more comparison. Now done. In this condition we have to turn towards left hand side, so we are dragging a left function block over here. Now as in the else condition, you can see the fourth condition appears. So here we are dragging one more if else statement. So the fourth condition will be when both sensors will be on black color. So here we are taking the relational comparison. So now in this we are taking count is equals to 1. It means when our robot will reach at the first intersecting line. What we have to do at the first intersecting line? As you can see, this is our first intersecting line over here. We have to lift this scrap tire from the left hand side of the robot. So for this, as we are taking the left crane, which is also connected to the port 3 only. So for that we have to stop our robot first, and to stop we are dragging a stop function block first. So again we are stopping this for a particular time. So for that we are dragging a time block. So the time we are taking is 2000 milliseconds again, that means 2 seconds. And after stopping we have to make our robot crane arm will move. So for that we are dragging a motor direction block, and this, as I told you, we have connected this arm with port 3. So when it will move in clockwise direction, so it will move its arm in up direction and it will lift the scrap tire prop. And for that we have to give some time for this. And this, the time which we are taking over here is 3500 milliseconds same. And after this we have to stop our motor, so we have drag one more motor direction block over here. On this we are selecting port 3, as we are taking with the port 3 with the screen. So now this crane will stop. After this, again what we have to do, we have to move forward. So the forward which we are moving is just to cross the intersecting line. So for that we drag a forward function block, and after this a time block over here. To cross the intersecting line we are taking the same time, 600 milliseconds, to just cross the intersecting line. After this crossing the intersecting line, we have to drag a variable arithmetic block to increment the counter. So for that, we in the arithmetic calculation we have to take count is equals to count operand plus, and again the constant value 1 over here. Now after this our value of count will become 2. So what we have to do at the second intersecting line, there is another prop called plastic box which is placed just nearby the second intersecting line. So here, and the most important thing, you can see this prop is after the second intersecting line. So for that, first we have to cross this intersecting line for some time, then we have to stop, then only we can lift this object. So for that, what we are doing, first we are dragging an if else statement, and in this we are taking the condition as count is equals to 2. So it means our robot will reach at the second intersecting line. So as I told you, we have to move forward. So first we are just crossing the intersecting line here. So we are crossing this intersecting line for a particular time period. The time period which we are taking over here is 700 milliseconds, because here we do not just have to cross the intersecting line, we have to reach at the block where the plastic box is placed. So after crossing here, what we have to do, we have to stop our robot. So we are dragging a stop function block. After this function we have to drag a direction block. The motor direction block is here to lift our robot, that prop with the arm of our crane. So this crane is connected with port 4, and now if we move it in anti-clockwise direction, then it will lift the object. So for that we have to drag a time block over here. So the time for picking up the object we are taking here is 3500 milliseconds again. So after this we have to stop our crane arm. So here we are dragging a motor direction block again, and now we have to select the stop direction with port 4, as this crane is connected with port 4. So after this, what we have to do, when we lift this object, we'll stop our crane and then again we start following the black line. So just before that we have to drag a variable arithmetic block over here. So in this arithmetic calculation, again we are giving the same condition, count is equals to count plus the constant value 1. After this, this block, the value of count will become 3. So for that we are dragging one more if else statement over here. And this, the comparison condition we are taking, count is equals to the constant value 3. So what we have to do at the third intersecting line, you can see this is the third intersecting line over here. So we just have to cross this intersecting line. So again coming here, if we are just to cross the intersecting line, we have to place the forward function over here and some time for this. So we are taking a time block over here. The time we are taking over here is again 600 milliseconds because we just have to cross the intersecting line, and after that the variable arithmetic block we have to place over here so that it will increment the counter. So here in this we are taking count is equals to count plus the constant value which we are taking is 1. Now after this block the value of count will become 4. So for that again we have to drag an equal, and this in relational comparison, now the count value of count will become 4. So we are taking when count is equals to 4, the comparison condition. Now what we have to do at the fourth intersecting line over here, this is our fourth intersecting line in the recycle plant. Here first we have to drop our both props in this area and we have to pick another prop from here. So in the program first we have, as you can see, again we have to stop our robot first. So for that we are dragging a stop function block. This is a stop function block we are dragging over here, and we have to give some time period for this. So the time to stop here we are taking is 2000 milliseconds, sorry. And after this we have to drop our both props. So for that we have to drag a motor direction block, this one. You know that our prop is on left side and another prop is on right side. So first the left side prop, which is a scrap tire, we are going to place that one. So we are selecting port 3 as scrap tire is on the crane which is connected with port 3 in the anti-clockwise direction, and the time which we are taking for this is 3500 milliseconds, same as we are taking earlier. So this is a 3500 milliseconds time. After dropping this prop, what we have to do, we have to turn so that our right crane also drop the object on the left hand side, which you can see in this. The prop which is on the right hand side, the plastic block, we have to place on the left hand side only. So we have to turn here. So we have to take the left turn. So we are taking left turn function over here. So this is the left turn function block, and we are turning towards left hand side first for 4000 milliseconds as I taken according to my model. So in 4000 milliseconds it will turn 180 degrees. So now it is able to drop the another prop, which is a plastic box at the input side of the recycle plant. It is turned towards left hand side. Now I have to drop the prop, so I am dragging a one more motor direction block over here. So on this, now this crane is connected with port 4, and when we take the clockwise direction, then it will drop the prop now. So now again we have to drag a time block. We are taking the time period of 300 milliseconds because we don't have to make our crane arm will drop that object uh, down below at the below position. So we are taking 300,000 milliseconds over here. After dropping this, again we have to turn towards right hand side. So to pick the another recycled brick prop. So for that we are taking the right function block. This is the right function block over here. So the time period for this we are taking is again 4000 milliseconds, as you all know. According to my model, it is taking, this time is taken by the robot to turn 180 degree. So this is the time. Again, if we have to pick the recycled brick prop, so we have to drag one more motor direction block over here, and the crane is which is connected with port 4 that will pick the recycled brick prop. So when I put that in anti-clockwise direction, then it will pick the recycled brick probe. So after this, I'm giving the time period to lift the probe again. So the time period I'm giving over here is again 3500 milliseconds. After this, when we lift the probe, then we just have to cross the intersecting line. So for that, again we have to drag the function block. The function which we have created just to cross the intersecting line is forward function block. This is our forward function block. So we are placing it over here. After this, we have to drag a time block over here. The time block which we taken to just cross the intersecting line, so that is 600 milliseconds we have taken. And now at the last, we have to drag a variable arithmetic block to increment our counter again. So here again we are taking the arithmetic calculation as count is equals to count plus the constant value here, that is 1 we are taking. So after this, our value of count will become 5. So for that we have to drag one more if else statement. Now and this, sorry for this, and this we have again to add, have to select the relational comparison. Here we are taking count is equals to 5 now. Now what we have to do at the fifth intersecting line, you can see this is our fifth intersecting line. So we just have to pass this intersecting line. So for that again, what we have to do, we have to again drag the function blocks which created to move in forward. So here we are taking the forward function block. This is the forward function block which we have to drag over here. Now a time block just to cross the intersecting line. The time to cross the intersecting line we are taking is 600 milliseconds again. Now after this, a variable arithmetic block again to increment the counter. So on this, in arithmetic calculation, again we are taking count is equals to count plus the constant value, that is we are taking 1 again. And now when after this the value of count will become 6. So what we have to do at the sixth intersecting line, this is our sixth intersecting line over here in this. So here we just have to drop the brick probe which we have taken. So for that we have to stop first. So for the stopping we are dragging our function block again. Now we have to drag this is our stop function block. We have to stop our robot first over here. After stopping, what we have to do, the brick, recycled brick which we are taking on the right hand side of the crane, which is connected with port 4, we have to drop that. But before that we have to give some time for the stop over here. So we are taking 2000 milliseconds over here. After this action block, because we have to drop our recycled brick prop on this. So for that the crane which is connected with port 4 and we put in the clockwise direction, then it will drop that recycled brick. So we have to give some time for that. So the time which we are taking over here is 3500 milliseconds again. And after this, at the last, what we have to do, we have to increment our counters. Sorry for that, because before that we have to stop our motor first over here. So we are selecting port 4 over here, stop this motor direction, and then we have to drag a variable arithmetic block. And in this arithmetic block, in arithmetic calculation, we have to give the condition again, count is equals to count plus the constant value 1. So after this, the value of count will become 7, then it will come out from the loop. And at the last, what we have to do, we have to drag a stop block. Now this is the program. Now you can save this program. I'm giving this name as a trash robot. So you can save it, and after this you can compile this program and burn in the brain.